And so, again, appreciate everybody being here today. Today, we are going to, if I go back to the beginning of this presentation, be looking at the concept of demystifying the testing requirements of the Commercial Energy Code. Right. So that's kind of what we wanted to kind of take an opportunity to just open up the book, look at what's going on, and maybe even, and I think it'll be a good conversation. If you have any questions, feel free to put it in the chat, raise your hand if you want to talk. We can unmute you. If you, we can, interactive is way more fun than just listening to me drone on. Remember, if you don't already, if your DLI is not in the system, let me know. So we'll be sending you your CEUs. You can always respond back. I try to put those in as quickly as possible so that you can obviously have those in your registry. But if you, for some reason, have a problem, have something missing, please let us know. If you don't get if there's something missing, more importantly, let us know. Remember, we are here as part of the Minnesota Energy Code Support Program, which is a program designed to support, educate, and empower you as building officials and building safety professionals throughout the state to build energy efficient buildings that benefit our community and our environment. That also includes if you have questions and you want to sit down on a one-on-one basis and do some plan review, or if you want us to look into some do a plan review with you on Zoom, or if we're in town, we can do it in person, or maybe I can send Gil up to meet with you if it's something big. And then while we're in town, if there's ever an inspection, if there's a best practice, you want to jump on, you want us to meet you somewhere, let us know what we can do to help you. We have no problem walking around building sites and doing plan review online. So again, it's a fun time and process. But if you have any questions, feel free to reach out, use our code helpline, talk to us anytime we can help you. So one of the things I think is important for us to remind ourselves constantly is if we understand the why, we can figure out the how. Because I think that's fundamental to understanding code compliance and explaining it in a way that makes sense to the individuals out in the field, whether that's a contractor, a designer, the public in general. Last week I was in a conference for the Midwest Energy Efficiency Alliance, and one of the things that my part of the presentation was incorporated that statement specifically, right? Because I think that it's important that we understand that we not only communicate to the contractors, but we also communicate to the public why we exist, why the building code exists, and that is to build and provide for a basic uniform standard for construction, right? We want buildings built in the state of Minnesota to be built at a basic understanding of what is safety, right? And not only in the context of is it going to collapse down around us, but then how do these buildings going to survive in inclement weather, bad situations, whatever may go on. Again, we know that Hurricane Helene or whatever you want to call it, came up through, and it affected even my area in Southwest Ohio, where again we had cities, nice cities, nice sized communities without power for 2-3 days. And so in those environments, as we're sitting at ball games and talking about it with some friends of mine, we were talking about how when they lost power, they have to think about what doors they open, what they, obviously their refrigerator, their freezer, they've got deer, they've got beef in refrigerators and freezers. And it's like, well, we have to watch out for that stuff. Well, you also have to think about how you're going to survive the night, right? We talked about whether or not it's cold up here in Detroit Lakes. Well, it's starting to get cold at home. And so we know that we need to think about how those buildings are going to survive, not only structurally, but also in their ability to control heat loss, right? Remember, building codes are all about control. And part of that is understanding how we control heat loss. And that is where we fundamentally get into this concept of today of how do we test whether or not we're controlling heat loss? And so that's really what the energy code is about, providing us that flexibility, giving us that basic understanding of what the code is looking for that long-term useful life of that building. How are we going to manage and control the environment that we've built? We know that the code addresses a variety of different types of buildings, including new construction, new buildings, new portions of buildings, new systems, new equipment, historic buildings, alterations and additions, changes of occupancy, right? When we transition from one type of occupancy to another, and it may come before the building department, then we need to know, right? And we need to evaluate how is that building going to comply. Remember, this is the code. And as much as I love to remind people, this is the code. I mean, some people will say, well, energy code is not life safety. Well, guess what? It is the code, though. And one thing I always remind my classes a lot of times, especially with contractors and design professionals, is I take pride in my job, and I take pride in providing my community with the best possible service I can. And that means knowing that I'm going to enforce the entirety of the code. And I don't want to be the one responsible for somebody calling up and saying, well, I wish they had done their job, right? I don't want to be that person, and I don't want you to be that person. So that's why we provide this type of training. But again, remember, there's a variety of things this applies to. When we think about how the code lays out, specifically in the energy code, remember, it's broken into these different subsections within each chapter. And those start to address mandatory, prescriptive, and alternative compliance paths within each of those different types or sections. And it really addresses what I call the four pillars, right? The building thermal envelope, which is what we'll talk about a lot today, on mechanical systems for heating and cooling of occupied or conditioned spaces, service water heating for use and functions other than heating and cooling, and then power and lighting, right? These are the basic four concepts that we're really looking at and when we think about energy code compliance. With that, I'm just going to jump straight into what's the mandatory expectation of the building envelope, right? We know that the envelope is that components, a series of materials and assemblies that control or separate the environment from the conditioned or occupied space. And then further within that, we'll talk about in a little bit that it also differentiates heated and semi-heated or non-heated spaces, right? That building thermal envelope is that control layer that allows us to control the environment within our building, right? And within that building, within that concept, there are three things that we're looking to control from a mandatory perspective. That's going to be the insulation, the fenestration, and the air leakage, right? If we roll it all down to it, everything begins and ends with the building thermal envelope, right? The continuity of that envelope impacts our building's mechanical systems, our power and lighting, our energy use associated with that building. And so that's why it's important for us to understand and control it. But insulation doesn't work by itself, right? Insulation provides that thermal resistance across the material. We've talked about insulation values and R values, the impact of R values and U factors. But insulation affects heat transfer, but it does not stop heat flow, right? If you took a piece of bad insulation, Pink Panther fiberglass insulation, and you applied a fan to it, you go on the other side, you can feel the air movement. It's not designed to stop airflow. It's to slow heat transfer, heat loss, heat conduction through that material. Now, we know that different materials react differently. And with that, we understand that insulation works with an air barrier to provide full compliance, full comfort, right? Right now is perfect what I call insulation weather. For me, when I go to the ball game next week or this weekend, I'm going to more than likely have an insulated jacket, a small. I've even got one here. I brought it from the airport, right? I've got a small jacket that's going to provide me some insulation to slow the escape of heat from my body, right? That will be different than what I wear in January and in December, January. And those of you, from up, know, especially in Minnesota, we know that adding another layer is always going to be something that we understand. And when I add to my thermal insulation an air barrier, I now completely encapsulate all the heat from my body. I personally don't usually wear an air barrier jacket, like a windbreaker or one of these large thermals, right? Because again, I overheat in the car. Now I'll wear it out in the ball game, but I'm not going to wear it in the car because I will sweat to death. And that's because I'm controlling not just thermal loss, but also airflow with that jacket. You guys, I know if I could see your head shaking or see your eyes, I would know that you completely understand what we're talking about. You guys know the difference between insulation and air barriers. So I'll move on. So now the code addresses, we skipped over it, the concept of fenestration within that context, because fenestration is an interruption in our building's insulation. And so obviously we've got fenestration, windows and door expectations. But what we're looking at today is really that third concept within that mandatory requirement, which is air leakage. Remember, it does no benefit to build a building and have the most efficient equipment in the world and then to allow a window to be open, right? That defeats the purpose of providing a high efficiency piece of equipment when the door is wide open. I've done that several times in my own personal residence where I've gone in and said, hey, somebody's got a window open. And I'll go upstairs and I'll realize, oh yeah, my 15-year-old decided he wants to sleep with a window open. How about you tell somebody, right? So we would, don't get me started. Don't get me started. 15-year-olds cause problems. But when we think about what's the air leakage designed to do, what is air leakage controls in place? Again, controls that we're thinking about for air leakage, we're looking at a continuous air barrier, right? And that continuous air barrier has to comply. We see there in the code, section 5.8.3. When we go to 5.8.3, what it tells us is that the materials that make up that air barrier have to either comply with the requirements of the code, which is going to get us back to air leakage rates, but those materials have to provide a level of air impermeability that we see provided in tables for 5.8.3.1, right? So that's really what we're looking at, is what types of materials, fenestrations, and doors are we going to have in our building thermal envelope, and how well do they prevent air movement through the wall, through that material? Now, remember, one of the things that was deleted by the state in the adoption of the code was this allowance for this exception in section 5.4.31 for semi-heated spaces to be exempt from our building thermal envelope for climates 0 through 6. They deleted that, which is good, in my opinion, is a good thing, because we want to make sure that even when we're transitioning from occupied to unheated to semi-heated spaces, we still want to control air movement. And obviously we're not in zone 2B, so the other exception doesn't matter. So again, we're really, again, reminding ourselves that in the state's adoption of the energy code, we're looking at a building envelope shall have a continuous air barrier, right? Now, very quickly remind ourselves that we need to know where that air barrier is going to be, right? We need to have it properly labeled on our designs, our details, our drawings, so that we can identify what parts of this system need to have what level of insulation, right? It changes the dynamic if I have a ventilated attic or an unconditioned space, and or a vented crawl space. I have a vented crawl space in my residence, and when they built the building, they installed a series of insulation. Well, guess what? I get that it slows it, but it doesn't stop it. You've got an open holes across that system. And so what we're trying to do is, again, how are we going to control air movement in and out of our conditioned and unconditioned spaces? Part of that, again, is we're looking at that continuous air barrier has to comply with the air barrier leakage requirements as well as the design and installation requirements, right? What that's telling us is that we need to look at that when we do whole building air leakage testing, we need to have testing that gets us a result of at least 0.4 CFMs per square foot of 50 pascals, 75 pascals of pressure. And so that is going to ensure that a building is either evaluated separately as either conditioned space and semi-heated space, or we're going to look at it together as a whole and then and normalize it over the square footage of the space, right? So we're either going to be testing that system either as 2 series of tests to ensure that the building's not leaking air from one conditioned space to a different type of conditioned space, from conditioned to semi-heated, or we're going to do the entire system and then do the average, right? this information has to be submitted to the building official as well as the owner. They should at least know that the material, and again, this is one of those requirements for that functional testing, uh, expectations of the code. We want people to understand that the building is being, that there are expectations on building tightness, right? We want to control. Um, a lot of people I conversate with talk about, well, you know, it sounds like we're doing too much. Well, my response is, do you want to have control over your own building or not? Right? You want to control how your building gets used. That's what the process is looking for. And the only way for us to truly identify that is through testing, right? But there are always going to be exceptions to the testing process. Not every building is going to be able to be done at a whole building level testing parameters or expectations. And so for that, the code allows exceptions based on building size. And with it, build it right, build it tight, ventilate it right. Exactly, Jesse. I think that's, again, I always like to remind, I have some friends who love nice muscle cars. And I always remind them, because they're the type of people that don't want, that think that the code goes too far sometimes. And I always say, do you want all 500 horse, or you just want 435? You know, because you paid for 500. Do you want 500 or not? It's the same concept with buildings. We expect the building to operate. I've got a project that I worked on, and the owner, I love him. I love this, but I don't say this with any bad thoughts or any bad connotations, but he's a penny pincher. He wants to know exactly how his building is going to perform, right? He wants to know every cost associated with his business, and from supplies and employees and all that. And if he has a expectation for energy cost, and it goes completely off the rails because someone didn't properly install an air barrier, he's not going to be happy. And again, the same concept comes when we talk about the types of types of air leakage testing that we're performing. So again, if it's over 50,000 square feet, we're going to allow for that area weighted average, and we're going to do that so that we test the systems under this rubric that we see identified in the code. I hate when I forgot this has these little drawings that come in there, right? So what we're going to be testing is everything directly under a roof, right? So if we have a 2-tier building that's 5 stories and 3 stories, we're going to test the roof under the 5th and the roof under the 3rd, right? Over the 3rd. And so again, we're testing anything that has a roof over it, because again, that's going to be an area that we're going to have potential pressure, where we're going to have air loss, potential heat loss. We're going to do any part of the building that has an entrance or loading dock, right? Where again, we're going to make sure that those openings in our building are going to be areas that get tested. And then we're going to do 25% of the remaining conditioned space, right? Whether that's multiple floors, how we're going to do that. Those are the values we're going to be testing. We're going to average those together to give us an area weighted value of how this building should perform. Now, remember the term building. Now, remember, this is where definitions matter, right? Because a building entrance is any doorway, set of doors, revolving door, vestibule, or other form of portal that is ordinarily used to gain access to the building or to exit from the building by its users and occupants. And so one of the things I think it's important for us to understand, and this has been one of those conversations we talk about in some of those exceptions associated with vestibules, is, you know, if we're installing a lot of doors, do we need vestibules in each one? Well, this is where we start to talk about, I'm not the AHJ, you are. But what this says to me is that these are entrances that are normally used to gain access or to exit. That's different from an emergency egress path or an emergency exit that's not ordinarily used. And it says this does not include doors solely used to directly enter mechanical, electrical, or other building utility service equipment rooms, right? So what doors we choose is really one of those conversations I think is important when we think about how we're going to look at this building as a whole. But if it's ordinarily used as an access point, then that's an entrance. There's those little drawings. Remember, as one of those additional exceptions within the air building, the whole building leakage requirements, is that If for some reason we come close, all right, this has been in IECC, this is in the ASHRAE standard. If our measurement comes close and we're within we're somewhere between 0.4 CFMs and 0.6 CFMs per square foot, if it's an employee access door, if it's ordinarily used, then I would say it falls under that expectation. Now, if I used to work at a Taco Bell as a teenager, and we had a door that people would go out to go smoke. That was not a building entrance. That was a door they propped open that was not designed to be constantly open, right? So I think that's where we start to get into that and have that conversation with your building department, especially. Obviously, they're the AHJ, but as for me, I look at normal paths, right? You look at that definition, and ordinarily used as a building entrance is different from a door that, again, I used to be when I worked for the city, I had a door I would sneak in and out of so that I could get away from contractors. Not that anybody ever does that, just me. But again, that was one of those. That's not an ordinary entrance door. That's just a door by which a person can gain access. Sorry, let me put a piece of gum in here. I'm starting to get a little vocal there. So what the code provides is if we have this air leakage testing and it comes back within the standard of 0.4 to 0.6 CFMs per square foot, we can then, instead of going back to retesting, we can go through a diagnostic evaluation. We can use smoke tracers, we can use infrared thermal imaging systems to conduct a building review to identify areas of leakage. We've done this a couple times. I've done this a couple times. It's actually, I enjoy it. It's kind of fun. Walking around with your thermal camera, trying to figure out where everything is. You then take that report. You have identified those deficiencies within your building thermal envelope, those air barriers. You document them. You document the repairs. You verify. I usually verify through another thermal imaging, and then submit that report showing that the corrective actions have been taken to the building department and the building owner so that you don't have to come back and redo all the testing associated with it, right? This is going to be one of those visual inspection alternatives that the code identifies when we've already completed a level of air barrier testing, air leakage testing. We also allow for verification by third-party agencies at some point, right? We allow that building department to accept, again, depending on what type of compliance path someone's utilizing, they may have a independent third party doing some of the work, and they can verify that barrier installation. Let's see what this one. So one of those options under those exceptions for the whole building is when we start talking about, for some reason, the building can't be tested or maybe wasn't tested, then the code official has the ability to utilize section 5.9.12 to allow for the verification of the design and installation of continuous air barriers that meet the requirements that we'll talk about here in a minute in section 4.5.8 as demonstrating energy or thermal barrier compliance. What they're going to do is they're going to do review, right? You're going to review the actual design and say, yes, we prescribed materials that match with section 5.8.3. Those materials were installed. We did periodic field inspections, verified that they were installed appropriately for their use as an air barrier. And then they're going to submit a report back that says, we have looked at the paper, we did the in-field inspections, these materials were all used, this is the continuity of our envelope, and then you can demonstrate compliance that way. So there's a paperwork version, but a lot of times that's a little bit more paper than people are willing to sign off on. And then again, for buildings that are group R, then we've reduced that expectation to the 0.3 that we see in the residential code, the 50 Pascal pressure that we see in residential. And then we also allow for that to be we require that to be an unguarded blower door test where we either are testing all of the units when it's under 7, or we're testing a series of units that match this diagram, right? That have 20% of the units, including units under the floor, under the roof, at the entrance, and then also the largest unit. One of the conversations we've talked about is the way the code is written. It could potentially include sliding glass doors, right? That may be in a multi-level unit. So again, if it's a building opening, right? We're looking at buildings that we tested according to the top unit, a unit in the top floor, a ground floor, and a unit with the largest, and looking for a mixture. And what it means by unguarded blower door test is that, again, we are testing only that unit. So either we test the entire building or a singular unit. We are not testing all of the surrounding units. Again, what we end up getting if we do a guarded blower door test is the potential is there that you've already pressurized. That's what that symbol means. You've pressurized these rooms. So are you really getting a true representation of that unit or of the entirety of that system? So if we're testing one unit, we need to know that unit is going to comply. How the air leakage issue remedy will work. Are we talking about, let me go back. We're talking about this one right there. I'm going to unmute you if you want to talk. Was that the question we're asking? So conceptually, if we're using if I'm understanding the question right, if we're using this diagnostic evaluation tool as an alternative to second or third air leakage testing with a blower door and all that kind of stuff, then what we're looking at is in that scenario is, again, you've done some level of testing, you've identified there's a leak somewhere, and walking around with a thermal imaging system, you should be able to see, and we've got some examples, you can actually see the temperature differential, right? That shows that air is moving somewhere this direction. Using that, you can then document what you did to correct it, right? If you excised a series of materials and re-insulated, resealed, did whatever you had to do, you document that. And in my opinion, the code doesn't say you have to do the second thermal. I always do it or did it just because I felt it was more confident to say, look, this was before, this is the after, this is what we did to get it there. And then you supply that documentation to the building department. Remember, we're not going for 0 as far as air leakage. But what it would be is it's one of those things that can say how do I demonstrate compliance without having to bring out somebody to do the inspection all over again? This is one of those conversations a lot of times I have with builders, especially some of the commercial builders, and say, hey, if it were me, I would, and I just happen to always carry it with me. So I digress. I carry around a miniature thermal camera, right? I don't think you can see that. We use this. We showed one of these at one of our in-person trainings, and so this device connects to. I don't know if you can see that, but this device connects to my iPhone, and then I can take thermal images using my iPhone. I was at a building last week, and it was kind of fun. Where it's walking around. It was an older building. It was a brick building that they didn't install a lot of. They kept it historic, so they just installed. They just sealed it, right? They used a sealer on it, kind of like an aero seal in their building, and they were able to get the air leakage to the right requirements. So I walked around with my cell phone, being who I am, and I was looking to see, is it really sealed, especially along some of the historic windows they weren't able to replace, and it was doing pretty good. There was one section I found that I said, I don't know about this right here. You got a little bit of differentiation. It was 1 or 2 degrees. But again, in a 3-story, 112-year-old building, that works. That device that I was just showing you online, Amazon, it was $200. and they have it for iPhones and for Androids. So digression. But I think that's, again, one of those tools. Like I tell my contractors, I would have one of those. And then you can walk around and show and demonstrate to your installers what they did wrong before you put up the drywall, before you do all this other stuff. Do a thermal pass and say, look, guys, we didn't seal this down here. We're gonna fail, and that's gonna cost me money because I'm gonna have to pay this guy to come back and do this test again. So again, that's just digression. That's how I usually see it. So blower doors, guarded, unguarded. Now we're gonna watch a video, so hopefully you can hear it all. So I'm gonna start the video. Now this is of a residential blower door test, just to be an example of how our blower door test operates. I'm gonna ask if you can hear it. Give me a thumbs up once it starts to play. Otherwise, I'm going to have to do something crazy. So. Can you hear that? Can everybody hear? Okay, you cannot hear. I can hear. Wait. Could you? No, I've got a bunch of no's. Okay, let's go back and I will okay, how do I do this? Share, advanced share. No. Share audio computer. Audio sound. Let's try it now.
So we're setting up for a blower door test now, and the first thing we need to do is put a tube from inside the house to outside the house, around the corner in essence, so that the turbulence from the fan exhausting air out of the house doesn't pass over the tube that's outside, because that can change your results. So we've rough fit the frame into the door, and now we're going to put fabric on the frame. The fabric gives us an ability to block off the door frame, but also install the fan so that the fan can exhaust air from inside the house to outside the house. So it takes a few seconds here to install that. It comes with this handy Velcro to keep it on the frame while we're installing it. Okay, so the fabric's on the frame now. Now we fit the frame into the doorway. Most often we put the frame in the front doorway, but you can put it into other openings to the exterior. Next, we're tightening the frame into the doorway so that it doesn't fall out. So you tighten it from side to side, tighten the knob, and then there's a cam buckle here that gives us an extra tightening. You do each side, make sure it's tight up and down, tighten this screw, and then cam it over on both sides. And then at the top as well. Helps if you're a little tall, I guess. And then our middle is done as well. So
now this can be done in residential or commercial.
Tighten down the
it's just a different size device, different size door frame.
The door is tight. Then we put our fan in. Whoops. First we need to bring the hose inside that I've run outside. So there's a handy opening here I can run the hose through, so I can measure the pressure inside the house in relationship to outside the house when I ultimately turn the fan on. And then I insert the fan into the opening here. There's a bungee cord inside this opening that cinches it down around the fan. It's pretty tight. But you just want to make sure that there's no gaping holes there. And then this green hose measures the fan pressure, which translates into the flow of air. Okay. Still filming? Mm-hmm. The next thing we do is install the controller. And then we install the gauge. So just like what we did with the duct leakage test, we're measuring pressure in the house in relationship to outside the house. Before we were measuring the duct pressure inside the duct in relationship to outside the duct. So I am going to measure the house pressure, which would be the input in reference to outside. So my first goes here, and then I'm going to be measuring the fan pressure in relationship to the house. And again, that fan pressure gets translated into a flow number. But we're actually, when we do the blower door test, we're going to do an automated test. So the computer will do all the measurements for us here after we've set it up properly. So we're getting ready to do an automated blower door test. So we're using Energy Conservatory equipment, so we're using the TechTite software that will run through a multi-point automated test. So I've set up the software to be ready for the house. So I've input the volume of the house and the square footage of the house and the testing points that will be measured here. I hook the computer up to the gauge and the controller, and it will tell me when we're ready to start the test here in a second once it's recognized. So that's highlighted here, so I can start the test. I have to tell it the indoor temperature, which is 75 degrees, and the outdoor temperature, which is currently about 77 degrees, and our altitude, which we're a mile high city here, so 5280 is generally what we use here. We start the test, and what it's doing is preparing to do a baseline measurement. So you can see here it's going to take about 200 samples, and then average those samples to get us a baseline pressure inside the house in relationship to outside the house. So that baseline pressure is negative 0.6. And then it's telling me I can open up the fan. We're going to start with ring A, and then I will proceed with the test. And I have to go take the ring off. And the fan will start running here in a moment. There we go. So the fan is going to ramp up to about 60 pascals of pressure inside the house in relationship to outside the house. It will take about 100 sample sets there, plot those on a graph, and then work its way down in 5 pascal increments 6 times. And we'll have a nice plotted graph. We'll be able to tell how airtight the house is. To set up the house, we've shut all the windows and doors. Any opening to the outside has been blocked off. We've made sure that the furnace is going to turn on and the water heater is going to turn on. It's especially important for the water heater if you have an atmospherically vented water heater, because you don't want any of those gases to backtrack while you're doing a house here. So we're just trying to measure the holes, the unintentional holes from inside to outside, which would include fan ductwork or other type of ductwork that is intentional from the house to the outside. Dryer vents, those types of things we don't block off during this test. So you can see we've done 2 measurements. We're doing the 3rd measurement right now here. We're just moving on to the 4th measurement here at, I believe, 45 pascals of pressure inside the house. So we've gone 60, 55, 50, 45, we continue to move down. We're just locked in on that 45 pascals of pressure, and it's taking about 200 measurements at that data point. You see we have a nice evenly sloped line starting to be generated, which means that we're going to have a successful test. The things that can impede a successful test primarily is wind. And wind can be a problem. There are some tricks to get around that, but that's generally when we have problems with our testing, is if it's too windy outside. Okay, so we're done. We need to cover the fan again. And we're going to do another baseline test at the end here. The protocols for doing a blower door test are now outlined in the ANSI 380 ResNet ICC standard, and that's what we're utilizing here. So the same temperatures that we had before we're going to input, and that's completed the test, and I can go to the next page here, and it tells me my something is wrong here. The air leakage in the house is 21 air changes per hour. So that must mean that I've mistyped my volume number. Yeah, I put the square footage, I reversed the square footage and the volume. So the volume should be 40664. And the volume should be about, or the square footage should be about 30, I think it's 37. I'll go back and fix that later, but you can see how that changes our results here. So the air leakage is now 2 air changes per hour, since I have the correct volume in the right spot on the software.
So I think one of the reasons why we kept that thing at the end is in the video is because it's important to understand that kind of manipulation, that kind of error in testing can really, as you saw, change the results. So it's not that people can't. I mean, Robbie is obviously an accomplished person at doing this. He's done thousands of them now, but you can still flop those numbers just like many of us do when we type things quickly. But I think it's worth pointing out that again, this is an example of a residential one. It shows how quickly they can be accomplished. We didn't see the part where he walks around and he double checks to make sure everything is actually sealed. That's another, we can always upload that to you. I didn't want to spend all day looking at those. But remember, when we're comparing, the question was how do we deal townhouses? Townhouses fall into the residential. Remember, residential, we're testing them. Each townhouse would be a separate unit. Or could be a separate unit depending on how we're looking at it. But part of the reason for that and why I put the comment in there the way I did was, again, I've had a lot of situations, and the code is moving towards that direction, where we recognize that individual unit has to be inspected. If it's less than 8 units, then you do each unit. If it's more than 8 units, that's when you're allowing that. Now we've gone commercial, and so we're allowing for that different flexibility, that other testing method. However, what we don't want to do is the middle unit becomes vacant, and the units on either side now have to compensate for the lack of air barrier control, air air loss control. One thing I've seen a lot. A friend of mine has a mother passed away. She owned a townhome, and so it's been vacant for several months, and she was still getting bills, and she wanted to know why. And it was because the even though it was set to a standard temperature, there was a lot of air loss going through the roof system. The roof wasn't insulated. It was not part of the roof itself. The structural roof was, but the ceiling they had a common attic space, and so then that created that heat loss, which is again is what we're trying to prevent. We want people, especially when we start talking about the cost to live, right? The affordability, and we want to make sure people appreciate and understand what they're getting. We need that continuity and understanding of it. Every unit should really be its own unit and have its own expectation of control in a lot of that situation. As far as what I would recommend for building officials participating, seeing these types of tests, I like to get out once in a while when I can to be a part of it, especially if I see one if I can see one in a subdivision, or if I can see one in a type of house, I like to do it. They're always fun to watch. That's why we like to show it on the video, though, just for many people who have never watched one. They've seen them. They've seen the door. They just never paid attention to what it is. Remember, in a commercial setting, it's going to be a larger series of equipment, right? Maybe different doors, depending on the size of the building, right? We're going to be having different equipment, but the concept is the same. We're going to have a mechanical test that we can verify those volumes. One of the other things, so when we think about those air leakage requirements of the code, those mandatory requirements, we talked about the continuity of our air barrier. That again, we can test and show that if there was an open window, that volume, that air changes per hour, that pressure would have shown air loss, right? Air loss equals heat loss when we think about it in this context. Same concept we talked about loading dock weather strips, right? They need to be equipped with adequate weather seals to restrict infiltration when vehicles are parked. We kind of see, a graphical version or a visual version of what those may look like in this scenario, and what they may look like in reality is they're gone, right? I personally take this as one of those opportunities to remind people about the education of building operators, right? If you know that you need to have this because it's going to save you the heating costs and expense, then maintain them, right? I know we're in the construction side and it's not about maintaining, but not about the maintenance all the time. But again, it's all about that education and people understanding. We're educating them, showing it worked at one point. And if you have, failing door seals or weather strips around your loading dock, that's, now you're going to know why. It was there when it was built. It's not there now. Within that context, let's see, some things we can do as a code official, know the formula, predict the tightness. Yep. And so again, I think that again, those are things to think about, and when you really start to think about how much, and again, I always get back to this, and I truly believe in the build it tight, ventilate it right. To me, it's one of those conversations I have a lot of times with contractors, especially when they want to argue with me about why we need to do this. I said, so are you telling me you can't build a wall that's flush to the ground? Is that I have to accept that there's going to always be failure in this building? I paid a lot of money, and especially with some of the places that people I know, it's like someone's paying you a lot of money to build a building, and they expect it to be done right, to have quality and pride in the product. And so it's not that far of a stretch to say, I don't want it to leak air. And when we're talking about what is 50 pascals, what is, 2 air changes an hour is a significant amount of air, right? When we're talking about, how many CFMs, how many cubic feet of air are moving each minute, right? We're not talking about, a whisper or a small breeze. We're talking significant amounts of air. And to me, it's not unrealistic to expect that if I'm going to buy or build a multi-million-dollar building, I want it to perform as expected. Digression as I move on. Also, one of the things that gets addressed is obviously going to be vestibules, revolving doors within that concept of airtightness. Now, again, vestibules and revolving doors are that kind of odd entity. I think we were talking earlier about a couple meetings ago about when we talked about this context about Menards and whether or not Menards has vestibules. I'm now intrigued, and I'm going to have some friends that I know that I want to talk to. But when we think about it, those entrances have to be either an enclosed vestibule, a revolving door, or a combination of the two, right? We want those entrances to separate our conditioned space from our exterior space. We know that the size that the code identifies for us, some expectations when it comes to the size, the spacing between exterior doors and interior doors, so that again we have this concept that every time I walk through, I should be able now there are going to be times when you've got a 5-year-old who wants to stand in the door and open it all the day long, but at the same time, a normal person should be able to pass from one to the other without leaving the door open long enough that air is just going to move uncontrolled, unfettered constantly, right? So we have calculations on the size. We have expectations for the envelope itself. Yeah. And comment is one of the comments is about Menards. I have a friend who works in a similar field, a similar organization. I'm going to ask about it and see where we get. It's an interesting thing about Menards, Lowe's, Home Depot, all those groups, Target, but I'm going to look into that. But anyhow, when we talk about the envelope, remember the envelope has to be compatible. Again, we're talking about the same reason why the state removed the exception to building thermal envelope associated with semi-heated spaces. When we start talking about vestibules, I mean, that's that transition space, right, between unoccupied and occupied, unconditioned, conditioned spaces. And so we're expecting that to have similar envelope expectations. Now, there are some exceptions. Again, when we're talking about doors not intended to be used as a building entrance, right? So again, if we've got a door that, going back to our point about is a door where a smoke break takes place considered a building entrance? In my interpretation of those phrases and the definition of an entrance door, I'd say no, right? We're looking at what is the expectation. We're not trying to play a level of control that is not the minimum expectation, right? Remember, codes are about minimums, and it's a minimum expectation that we're thinking about vestibules in the design of our building and how it's going to affect the uncontrolled, unfettered heat loss in that building. So again, there's a variety of different exceptions that are laid there, especially vestibules for larger structures, larger spaces. And again, we're talking about the space between, or the way we pressurize and depressurize air movement or control air movement in and through those spaces. And sometimes, again, you'll have different temperature controls. When we talk about some of the mechanical systems, we'll talk about temperature controls of maybe heating devices inside this area of the vestibule, those kinds of things. Again, we're looking at maybe transition spaces within already occupied or semi-heated spaces. If we're in a large mall and the mall has an open area, we don't need to install vestibules in between the stores because, again, it's not a significant enough heat differential to create that need. So we don't have a whole lot of time. I will remind you of I put the slides in here in case we had extra time, but at the same time, I also threw this one in to remind us. If you have questions about the air barrier itself, remember we talked about devil in the details, air barriers back in July. You can go back and watch that on the website. Is there an exception for historic buildings entrances as shown? I believe in the historic section it is in the chapter 5, not chapter 5. I'm thinking energy code. We will be doing a class on historic and unique buildings. But yeah, when we go back to the scoping, looking at the wrong screen. I'm used to having my screen. Right? When we start talking about historic buildings, we're thinking about what can we do in that context, right? We're not going to require or expand the expectation, but what can we do if there's exposed areas? Again, if it's maintaining that weather stripping, right? The facility that I went into last week, again, they had they installed a vestibule into their space on the interior side, right? It's a large brick, admin building for a former manufacturing facility, and so they maintained the door, but then they created the vestibule to thermally isolate the two spaces. Go back down here. So again, there's a variety of things that we can look at. Again, if we're seeing something like this and a nice, beautiful, maintaining this door is just as much for preservation of the historic nature as well as maintaining my airspace between the two, right? I should not see, and I've been in hotels and I go to hotels a lot now. And so I've done my thermal check of the hotel door in the restaurant area. And you can see, I've got an example of one in I think one of these diagrams. Let me see. Where you saw a 20-degree shift, 20-degree swing. Oh, nope, I didn't put it in there. But using the thermal camera and the thermo gun, it's a 20-degree difference between the broken bottom seal on that swinging door and the interior space. Again, very small issue, a lot of heat, a lot. It's going over time going to affect how that building operates. Again, sorry we didn't have time. Now, when you get these images, when you get the PowerPoint, there will be a series of maybe 20 to 30 slides here that go into greater detail about the air barrier. Feel free to look at them. Again, go to that website, go to that video if you have any questions. And then again, remember that when we're testing these, we're looking at the types of materials laid out in the code. Now, we didn't get into it. I don't know why I put that there. But again, remember this air barrier is where we're going to get into that list of different materials that can be used to demonstrate, there it is, to demonstrate compliance, right? That table 5.8.31 is going to be that list of 16 different materials, 13 materials that are deemed to have the air impermeability rate that's required by code, as well as a couple of assemblies that meet that expectation. And so the expectations for field installed or field fabricated air leakage of fenestration is provided in the code. So that's where you're going to find those types of details in section 5.83. I know we've got 1 minute left, and so I'm going to remind you about the survey. If you have questions, if there are topics we should bring up, if you're interested in hosting one of our in-person trainings, either as the full 4 hours or as a smaller subset just for your community, let us know so we can get those on the schedule. So we're going to probably be meeting here the next week or two, next couple weeks, to try to start working out the first quarter of 2025. But if anybody's interested, let us know. Remember, we do have, for those of you that are interested, we've got obviously our upcoming webinars, our in-person training in Mankato at the end of the month, as well as, and if you weren't here at the beginning, we are going to be doing in these off weeks on Thursdays at the same time we're doing this, we're going to have best practices webinars. And the one I'm most excited about, and I think you guys might have fun with, is ComCheck as a resource on Halloween. It's not that scary, even though it is Halloween. So we'll go through that ComCheck, go through a ComCheck on a project, talk about it. These are a very interactive opportunity for you to get together. And then for those who might be interested, there is going to be a virtual 4-hour class for plan review associated with thermal envelopes. So again, Hope's going to go through an actual couple of plans and show you how they do that. And again, it's another opportunity. It's a longer class. Those are not kept or put online, but you can always ask us. And like I said, if you have any questions, if you want to jump on a Zoom to sit down and talk together, look at a plan together, let us know. You feel free to use our code helpline. If you have any questions, we can always help you with. And then I may wear orange on Halloween, Gene. you never know. It'll be kind of scary. But if you do have questions along the way, feel free to reach out to us. And again, we are here to assist you for free in any way we can. That means helping out with plan review or maybe joining you on site one day. Let us know if we'll be in town, and we'd love to meet with you and put faces with names. It's always the best part. You guys have a great week. Be careful, be safe, and I will see you. Well, if you're doing the virtual, I'll see you next week as we talk about manual J's. Otherwise, I'll see you guys in a couple weeks.